Because what you don't know about energy can kill you. Here's Alex Epstein.
Welcome to Power Hour. I'm your host, Alex Epstein. Now, for the last 3 weeks, I have not been your host. My co-hosts, Don Watkins and Stefan Henna, have taken over, and we've gotten pretty good feedback on how they did. So thanks, Don and Stefan, for taking over. I guess I should say hi to you guys today because they are here today as well. Hey, Don.
Hey, Alex.
And Stefan.
Hey, everyone.
So you guys covered a lot of interesting topics while I was gone. I was gone in the sense of having a whole bunch of speaking engagements and other things concentrated in early June. And I was also just doing a lot of work on Moral Case for Fossil Fuels too. So Don and Stefan generously offered to take over for a few weeks, but now we're back and hopefully it's even better this week. I see that you guys have a lot of interesting topics, and I have some new thoughts and new perspectives that I've been developing while I've been away. And I'll just introduce some of those as we go on. But let's start off with Don. Don, what's your first story for today?
Well, the publication Vice has kind of set off an interesting debate with an article they published. New report warns high likelihood of human civilization coming to an end within 30 years. So that's pretty bad. And what they were doing is they were summarizing a study or a publication from the Breakthrough National Center for Climate Restoration, which is an Australian think tank. And basically what it said is that the IPCC report understates how much harm climate change will do, and that the runaway feedback effects that are amplifying the warming from CO2 are going to make the Earth largely uninhabitable. And it doesn't say that the body of the article doesn't say that will happen in 30 years, but that 30 years will be the tipping point where we really can't do anything to stop it. And there was some pushback from climate scientists. In fact, there was one detailed response from 6 researchers who said that the claims in the report were overstated, and then the claims in Vice's article were even more overstated. And just one example, one of the climate scientists said, the report's authors have merely read or possibly seen without actually reading a few of the scariest papers they could find, misunderstood or not properly read at least one of them, and presented unjustified statements. So pretty damning stuff. But the researchers went on to say, like, look, this is still a catastrophic problem. You don't need to oversell it. And a headline from Vox really captured the flavor of the debate, which was, will climate change kill everyone or just lots of people, or lots and lots of people? And so what you're really seeing is this mainstream debate about whether climate change is a catastrophic threat or an existential threat. And if you look so what's the whole basis for this debate is, look, we have a pretty good sense of how climate is going to respond to CO2 thanks to reliable climate models. And so now it's just like, how dead are we going to be? And at the same time this debate was going on online, the New York Times published a really interesting op-ed called "Is Climate Change Inconvenient or Existential? Only Supercomputers Can Do the Math." And the author was Sabine Hosenfelder, a research fellow at the Frankfurt Institute for Advanced Studies. And Sabine points out that according to the IPCC's 2014 report, predictions from about it was based on predictions from about 24 computer models. And she says, I assume it's a she, but Sabine is an unknown name to me, so maybe Stefan can correct me. While similar in methodology, the models arrive at somewhat different long-term projections. They all agree the Earth will continue to warm, but disagree on how much and how quickly. And I mean, that by itself is a pretty big red flag. That is, if we have this really good understanding of the climate, it should at least be a question. Well, then why do the models disagree significantly enough that a researcher is pointing this out? But then Hossenfelder goes on to argue that there's one particular equation that can't be solved at present that creates huge uncertainty in climate predictions. It's and I might botch this pronunciation too, but the Navier-Stokes equation, which is the formula used to calculate changes of the atmosphere and oceans. And the article says the Navier-Stokes equation, central to predicting Earth's climate, is famously difficult to solve and has caused mathematicians and physicists headaches for 200 years. It is knowledge we urgently need. As Earth continues to warm, we face a future of drought, rising seas, and extreme weather events. But for all we currently know, this situation could be anywhere between a mere annoyance and an existential threat. And so Hossenfelder's view is we need to spend about $1 billion on supercomputers that can work out this equation and tell us what we need to know. But just this, like, if the science is settled and if the only debate is catastrophe or existential threat, and if all we have to do is listen to the scientists, then, like, why do we need this? If mere annoyance is actually on the table, why is that not at all discussed? And anyone who does discuss it is labeled a denier. And I think this points to a point that you made in the moral case for fossil fuels, Alex, but that is it's treated as off the table, which is that the whole foundation here is climate models that have not successfully been able to predict the future paths of climate. And it really illustrates that we have a gigantic lack of understanding here, and that nobody takes that into account, or you're not even allowed to acknowledge that, except in this particular case in the New York Times.
All right, I have a lot to say about this. Let me just start with the issue of climate prediction, which I think there's a bunch of ambiguity there that's worth resolving. So, in a sense, we can divide climate related prediction into, I think you could think of it as, I tend to divide it into three categories, although you can simplify it into two categories. So the version of the three category version is you can divide it into how good are we at predicting the change in average temperature. That's kind of one thing, because the whole theory of catastrophic climate change, or at least the claim of catastrophic climate change, the fundamental driver of problems is warming by a rise in greenhouse gases. So there's the question of, okay, when you increase greenhouse gases, particularly CO2, what does that do to temperatures over time? So that's one thing where prediction is needed. And then another aspect of prediction is when temperatures rise, what happens to other aspects of the climate system, of the global climate system. So that can be, what happens to, what kind of influence does it have on sea levels? What kinds of influence does it have on rain patterns? And then that itself can influence drought and storms and a bunch of other things. And there's also wildfires, but you can think of it as, okay, the warming influence. So there's like the warming influence of CO2, and then there's the broader climate influence of warming. So that's part two. And then three is you can think of it as like the climate influence on human flourishing. So you have, like, again, rising CO2 causes some amount of warming. That warming causes some amount of broader climate change. That broader climate change has some sort of influence on human flourishing. Now, so this is a human flourishing perspective on it, which is, I think, is the proper perspective. So if we look at how well are both of those understood, I'm curious about Stefan's view on the first two, but I would regard as the first two are pretty poorly understood, and probably a second is considerably worse understood than even the first. And so when we talk about climate prediction models not being able to predict climate, and we talk about the uncertainty there, there's a huge uncertainty in terms of how much influence this has, although we've had a long time of increasing CO2 in the atmosphere, and it hasn't been anything very dramatic. And I don't believe there's been anything very dramatic climate-wise. So that's definitely a positive indication. And we know things like, well, CO2 levels have been 10 or 20 times higher in the past, and temperatures have been much higher, and that kind of thing. But so there's a lot of uncertainty about what the climate system. But in terms of how the climate system impacts human flourishing, we actually have enormous confidence in that. And but it really depends on our understanding of human nature, because the way that most people who are talking about climate prediction treat human beings is that a change in climate conditions will fundamentally disrupt human beings' now stable existence. So there's this idea of, well, we depend on stable climate conditions, And if those change, so if that situation is destabilized, then we were used to growing crops one place and now we're not going to be able to, or we're used to having more water here and now we're not going to have it. And then they see it as, well, we have this system that depends on a particular set of climate conditions, and when those conditions change, then it's going to be a disaster. And they just run these simulations in effect. Sometimes they have simulations, sometimes they just have their own conclusions. But the idea is that they treat what we can call like the human flourishing system or the human life system now, which is a huge part of it is the economic, you can think of it as economic system. They treat that as a fairly stable and static thing where changing conditions destabilize and ultimately harm it. And this is very much a view held by a lot of people in the environmental sciences and people talking about this, but it's important that this is a known false view. That is that human economic systems are stable and that changes in conditions, even significant changes in conditions, lead to their decline. The way that the human flourishing system works is it's a very dynamic system. So it's a system where we are constantly dealing with changing conditions, and the overwhelming source of those changing conditions are our own economic advancements. So you think things like, well, we increase the number of people, and so we have to make changes there, or we use iron ore in a certain place, and then it's no longer in that place, so we need to use something else. Or computers come along, and that totally changes what's valuable and what's not, and where it makes sense to use resources, and that changes people's jobs and whatnot. So human life, like the human flourishing system, is a constant process of adaptation and mastery in the face of changing conditions. And it's generally one where the conditions are always changing and life is overall getting better because we are a dynamic species, at least when we are left free. So when people talk about things like, oh, well, temperatures will go up, or storm patterns will change, or rainfall patterns will change, like all of those things are things that sea levels rise, and particularly because you're talking about fairly long time scales, human beings are completely able to deal with those kinds of changing conditions. And really, above all, the science of economics should really be voicing this and telling us this, that we are just incredibly, incredibly good at dealing with changing conditions, whether they come just from the natural environment, whether they come within our own economic system, or whether they come from the side effects of our economic system on the natural environment, which is the claim of climate influence. Basically, there are activities that we're pursuing energy and productivity and flourishing that has a side effect, and that's going to change climate conditions in some general way over some period. So when we talk about, oh, well, climate models don't work and stuff like that, it's important that the most important piece of the equation, which is how human beings deal with climate conditions, is both very well understood and very positive. And it is completely being ignored by most people who would consider themselves scientifically savvy. So the science of, I mean, there isn't even a good name for this because it's partially economics, but it's basically like the science of human flourishing, the science of human action, and specifically with, you can call it the science of human mastery. This is something that we are incredibly there's a lot of available knowledge. We can have a lot of confidence, and we know that we can deal with all sorts of changes in conditions. I think that is, and then of course, if you get that, then you are much less afraid of different kinds of changes in climate conditions. But on the other hand, you are more afraid of anything that changes the fundamental conditions that mastery requires. And so what does mastery require? Well, mastery definitely requires freedom. So it requires that we are free to think and act in different conditions and as conditions change. That is essential. If the law forces us to be static, then that will be catastrophic, particularly just given the nature of life and how dynamic life is. And then we need to be free, but then we need to be free also to take the kinds of actions that give us mastery. And one of those kinds of actions is we need to be able to produce energy so that we can use machines to master our lives and master our environment. And that's why all of these policies to threaten energy abundance are so deadly, because when we have energy abundance, that's an indispensable ingredient in our mastery of our environment. And if we have that ingredient along with freedom, we can do so much, and we really don't have to be worried about a whole lot. But if we take away that ingredient, if we take away energy abundance, then we are very, very crippled. Like kind of, even if we have everything else, but we just take away energy abundance, well, then we don't have much ability to use machines. And then no matter how smart we are, we're mostly left with manual labor. And that gives us very little power to act, to do work. And it also prevents us from using all of these amazing machines that don't work via manual labor, like computers. So it's really interesting how there are all these different speculations, but what is really the thing that's really known is that human beings with energy abundance and freedom can deal with any kind of changing conditions. And I think that changing climate conditions are nowhere near the list of the top challenges that we will face. But a challenge that we can't cope with would be deprivation of energy, and that's what's being proposed. One final perspective on this is just that I find it very, very helpful to just think of energy much as you think of medicine or drugs, like prescription drugs, including, or you can include vaccines here. And just whenever I hear any of these claims, I just think about benefits and side effects. So if somebody is saying, oh, well, we're like, I'm sure this will come up in later stories because you just see it all the time, but they'll say like, oh, fossil fuels, like fossil fuel air pollution kills X number of people. And if you just translate that to vaccines, you see a story that says vaccine side effects killed X number of people. You think that is a bad story, because you can't talk about what the side effects are doing independent of the benefits. And if you just look at the side effects, you think, oh God, those vaccines are terrible. But if you look at the benefits, then you have a very, very different evaluation. So thinking of, I mean, these are very two related points, but the second point that I've made is just the thinking of energy and particularly fossil fuels in terms of the benefits and the side effects, just like you would any kind of medical choice that you're making. And then recognizing that whatever our uncertainty about climate prediction, we have enormous available certainty about human mastery over changing climate conditions and changing any kind of other conditions. Stefan, what's your first story today?
So there has been a piece of science communication artwork, I would call it, that has been going viral for some years now. And I want to take this opportunity to talk a little bit about what can go wrong with this kind of artwork. So back in 2016, Randall Monroe, otherwise known as XKCD, an author of a viral or very popular online comic strip, published a world temperature record going back 22,000 years ago. So let me just describe how this comic looks like. So it's essentially a time axis spanning from something like 20,000 BC to today, and then into the future to the year 2100 on the x-axis. And on the y-axis, there's a temperature anomaly, so the global temperature anomaly, spanning from like minus 4 degrees C to plus 4 degrees C. And so it's a very
wait, can I try describing it? Just
yeah,
because
sure.
I think some people might be able to get that, but I'm looking at it right now. And by the way, a friend of mine in San Francisco, Alex Lloyd, has asked me twice now to comment on this. So I figured, okay, let's cover this. And I thought Stefan has a lot of good perspective on this, and I have some thoughts as well. So it starts out at the top. It says a timeline of Earth's average temperature since the last ice age glaciation. And then it says, when people say the climate has changed before, these are the kinds of changes they're talking about. So the overall idea is to show unprecedented climate change recently. And, they're trying to counteract the idea that, well, climate is always changing. They're trying to show, well, no, recently there is an unprecedented climate change, or at least an unusual kind of climate change. But which, by the way, it's totally possible to think that and to still think that that change is completely manageable as long as we have a lot of energy production and a lot of freedom. And that's going to be one thing that's left out of this, is that it's just totally focused on the side effect that is climate change is also distorting that, but it's not focused on what's happened to human flourishing during this time of climate change. Because you can imagine something that would be like, oh, here's a timeline of medical side effects in the last 20,000 years. And oh my gosh, there's been a real proliferation of medical side effects in the last 100 years. And the medical side effect, intergovernmental panel on medical side effects projects even more unless we dramatically reduce the causes of medical side effects. You think, well, maybe it's good that we have an increase in medical side effects because we have an increase in the use of medicine, and maybe that has a big impact on human flourishing. So that's going to be here. But just to show you, so what happens is, at the top, what you see is it says temperature, and then on the far left, it says -4 degrees Celsius, and it goes to 0, and then it goes to 4. And the -4 has a kind of blue to it, and the kind of a light blue, and then the +4 has kind of a red, which people I think like red because it's a little alarming. Although this isn't nearly as alarming as many reds that are being used. And so what you see then is you go down this, and it starts at 20,000 BC, and then it goes in 500-year increments. So it goes 19,500, and then 19,000, et cetera. They go BCE, before the Common Era, so which is the same as BC, but people like to use BCE sometimes. So they're going down, and basically what you see, it starts at, so the anomaly, I should just say, is the anomaly is like the difference. It's like how different the average temperature is from our average temperature today. So in the middle is 0, and they're taking it between 1961 and 1990, which is interesting why they take that as the number. But so they're starting at something like -4 and a third. So they're showing, okay, it was really cold back then. And then you can imagine, it's going to start warming up at some point. And so as you go down, they have a bunch of different events and stuff, and I'll let Stefan fill in some details. But in general, you have the thing going slowly to the right, and then near 1500 BCE, it goes faster to the right, interestingly. And then they're showing it goes to the right. And then at like 11,500, it starts going to the left. So it starts getting cooler again. And then it starts getting warmer at 10,500 BC, and it gets actually quite warm. I mean, it's pretty significant. So it's developing farming, and through 9,000, it keeps getting warmer. They start to cross past 0, and then they keep going. So like 8,000 or 7,500, it kind of stabilizes for a while. There's like little cooling, little warming, but you're seeing it stable for like 8,500 years, and then it's sort of cooling a little bit as you get to the year 0. And at the year 0, it kind of is at 0, like the temperature anomaly is 0, and then it gets a little bit cooler, but it's staying pretty steady for 8,000 plus years, and then it gets cooler after 1,000, which is going to be an interesting thing because there's some medieval warm period that was widely acknowledged. And so basically it's getting cooler until about 1850. And then what's happening is it starts getting warmer pretty dramatically through maybe 1960 or 1970. And then you see this significant thing where it's now going up into the, 1 degree above. And so what you're seeing is you're seeing you're sort of seeing a more dramatic increase than you've seen in the past. But then in particular, what you're seeing is, now granted, they put this in dotted lines at the end, but then you see a really dramatic warming in the future. And it says current path. So it's like the current path says, wow, we're going to get warm really, really quickly. Like we're going to go into this territory that seems unprecedented by 2100. And then it says, okay, the best case scenario is that it'll level off, assuming immediate massive action to limit emissions. So what you see is then it stops warming altogether pretty soon. And then by 2100, it's not that much warmer than it is now. And then there's an optimistic scenario, which the warming is less, but still quite dramatic in this. and then current path. So hopefully that give you some indication. Of course, you could just look at this. We should put a link to this, but it's at xkcd.com. And so the idea is, there was a bunch of warming and cooling in the past, but today's is really unprecedented and we are heading in a really bad direction. And so we should probably do this best case scenario. So I have some thoughts, particularly on the labeling of best case scenario, which I would not regard as a best case scenario. But Stefan, what did you want to say about this?
Yeah, so one thing that strikes everyone who looks at this is at the very end, so the modern era looks so much different because it changes so sharply in one direction, and it really, if you look at it, so this is a very lengthy image. So you scroll through the thousands of years for a lengthy amount of time, and then suddenly this big spike comes up. So this sort of is intentional to give you the impression that this is totally unprecedented and a total, like, almost 90-degree switch in rapidness of the warming. And so one feature of this lengthy line is that it's sort of very smooth and it wobbles around and it's very gradual in its changes. Like, even if you see temperature changes going from -4 to 0 and then up again a little more, that is over very lengthy periods on this time axis, and it's very smooth and doesn't change quickly at all. So it changes gradual, and it's just the magnitude comes with the length of time. And towards the end of that graph, it's really a very fast-paced change. And so this is suspicious. And so what's good at XKCD is that they give an explanation file and give the sources and so on, so people can look things up. So, and what you find is that, for a lengthy period of time, so they use proxy data, right? So they use some data they derive from papers that use proxy data. So this is, for example, tree rings or clam shells in sediments or ice core data that sort of gives you an estimate of what historic temperatures might have been. And that is then glued together end of the 19th century with the modern thermometer record, right? So this is the first time when sophisticated nations started to systematically get temperature records, and from that you can estimate better and better the global temperatures in real measured form instead of deriving it indirectly from proxies. And then at the end, of course, it's glued together with IPCC predictions of future warming scenarios. And so the sudden change is quite problematic because, and this comic, of course, created some media echo and then was discussed by experts. And one of the problems that turned out is that the authors of the papers for the proxy data then said, okay, we don't actually look at the question whether this is a really rapid change. And one of the problems is that our proxy data on average smoothes 120 years in the temperature record. And what that means is that you essentially get an average value for a very lengthy period of time, over a century, for most of this graph. And then when the modern temperature record comes, it's smoothed a little bit in this comic strip, but it's actually a much shorter period of time. So naturally, just because of the mathematics involved from the smoothing or from the actual data record, the temperature shifts before the modern thermometer record cannot shift that much in a time period. So there could be wild swings in reality, historically, that we cannot see in the sediments. We just get an average value over a lengthy period of time. So maybe there was a much more rapid warming. We know, for example, that, or we have a really good idea of that there was a Minoan warm period, a Roman warm period, medieval warm period. And so when the Vikings settled on Greenland and so on. So we have some idea of changes that took place at a relatively rapid pace, not in human terms, but in geological terms. But you cannot really see that in this proxy data. And this was just simply then glued together with the modern record, which shows more, short period rapid changes. And then, of course, the climate predictions, that's not actually data, that's somewhat speculative. And another problem I have with that is that you don't see any indication of uncertainty. You get a dotted line and a full line and then a dotted line again, but nowhere in this is an indication that, oh yeah, this could be temperature 0 degrees, or it could also be plus minus 2 degrees or something like that. You would normally in the data, you would see at least some indication of uncertainty. You don't have that here with any of the data sets. It's just a straight line. And it looks like, oh, we know precisely what kind of temperature we had, in 1000 BCE. And that's not true, of course. And then again, towards the end of that, we don't see any indication of how uncertain actually the predictions are, the projections to the year 2100, right? So these are model calculations. And one of the things that you only know if you've seen the model or the model outputs before is that there are actually different models that predict vastly different things. Like there can be a difference of 2 to 3 degrees centigrade between single model outputs for a certain emission pathway. So, there's some uncertainty for sure there, but there's no indication of that. It's just they take the mean and then plot it and say, oh, that's what science says. And that gives you a very false impression of what we actually know and with what kind of precision we know. And that's some of the problems. So it glues together data that is not really compatible and makes no real indication that there's a difference between them. Then the smoothing isn't, well, it's alluded to in the comic. There's some, oh yeah, this proxy data actually smooth things, but only the really extreme spikes, or only the slight spikes would be smoothed out, which is not true. 120 years of average temperature, think about what the average temperature would be if you would just average the entire thermometer record. It would be totally no change for the last 120 years since the beginning of a modern record. And vague IPCC reference, no indication of uncertainty there, no indication of different models tell different things. And so this gives you the final impression that, oh yeah, we know precisely what temperatures were in the past, what they are now, and what they will be in the future if we don't do X. And the comic strip itself says specifically, this comes from fossil fuel CO2 emissions, and that has created this warming in the late 20th century.
All right, so those are some really interesting details. Let me just give my summary of what's going wrong with this. So I think of this as these kinds of infographics or info cartoons. What they're trying to do is give us perspective on something that's important to our lives. And I think they can be very, very valuable. But I think this has at least 3 huge problems with it. So one is it's just focused on the side effect of something that's incredibly beneficial, namely fossil fuel use. So, fossil fuel use, the fossil fuel industry has given us and continues to give us this unprecedented energy production that allows us to use machines to improve our lives on an unprecedented scale and make possible a way of life today that's completely unprecedented, at least for the billions of people who have it. And there are billions of people who want it and who don't have it. So you have to, it's distorting to just look at the side effect of a profound value, but not look at the benefits. So that is, I'd say, the most fundamental distortion. But then within representing or misrepresenting the side effect, it misrepresents the past. And in particular, it misrepresents how stable and smooth the phenomenon related to the side effect is. So as in average temperatures. And it's misrepresenting them as far more stable and smooth than they are. So that's going to then give us a distorted sense of the side effect so far. And then I actually think it even in terms of like the side effect, insofar as it is a side effect in like the last 200 years, I think that is not, there's not enough precision there. But then the biggest thing is, so you're misrepresenting the past. That's point two of the side effect. And then, or the area related to the side effect. And then the other thing is misrepresenting the future, acting as if you have a large amount of confidence that a certain kind of prediction will hold true. And so that is a real distortion. So when I look at this, it gives you this idea of, oh, wow, well, this is a real problem. Like we're facing a real problem because this force in our lives is dramatically changing our climate in unprecedented ways. And so you have a much more dramatic picture of what has happened, and then even more dramatic and inaccurate prediction of what will happen. And you have no context of the benefits. So I do think it's a pretty good analogy to think about, like medical side effects. And if you were to look at that, you would surely see, oh yeah, well, those are generally increasing. But if you just had that, let alone if you misrepresented it with the kind of distortions that XKCD has and the particular papers he's relying on, have, then you'd get it even more. But the biggest thing is, can't look at the side effects apart from the benefits. Don, what's your next story?
So, United Kingdom Prime Minister Theresa May, she just announced that Britain would be eradicating its net contribution to climate change by 2050. And so this is a legally binding target based on recommendations from the Parliament's Committee on Climate Change. And basically what it does is the United Kingdom had already committed to cutting emissions by 80% by 2050 compared to 1990. And now the target is net zero by 2050, which doesn't mean no emissions, but that any CO2 emissions have to be offset or removed. And it's not an actual plan. But if you look at the committee's recommendations, you get some indications of what the commitment would require. So they talk about by 2035, all new cars must be electric. All buildings must be retrofitted and decarbonized. People must consume less meat. Thermostats in the winter should be set no higher than 66 degrees Fahrenheit. And the thing that is striking to me about this, well, there's two things. So one is Extinction Rebellion, which is this criminal activist movement that we've talked about in the podcast before. They describe this as a betrayal. So there's just one quote from their Twitter account. Let's not mince words. 2050 is a death sentence. People are already dying, and this will only get worse with far off dates. Were we to put our minds to it to address the threat, the UK could embrace transformative change and decarbonize in years, not decades. And I mean, just FYI, the UK gets, like the US, about 80% of its energy from fossil fuels and about, a few percent from so-called renewables. So the idea that this is doable in a few years for many reasons, but just that gives you a sense of like, it's delusional to think this is a couple-year program. But the thing that I really found disturbing about this is just the whole idea of the government setting fundamental economic goals, which is essentially what this is. It's we're going to rearrange the entire way of life of Britons. I mean, what kind of cars you're going to drive, how warm you're allowed to keep your house or apartment, and like even what you're eating. And, I think often in debates today, like, saying, oh, this is socialism is kind of thrown around in a really loose, meaningless way. But this really is fundamentally like socialism. It's that you're going to central plan the economy. The only difference is the old socialists were pretending that we're going to have the government plan the economy in order to achieve progress and prosperity. And this is we're going to plan the economy in order to reduce progress and prosperity. And, we'll see how it plays out in actual practice. But just that this is considered idealistic rather than terrifying is what I find terrifying.
Yeah, I mean the means are horrible, but I mean just if we're thinking about energy from a human flourishing perspective, it should just be a huge alarm bell to say we are setting a goal of in effect, zero side effects by X amount of time. I mean, I've been using this example a lot today, but if you said, like, okay, zero vaccine side effects or like vaccine neutrality or something like that by 2050, you'd think, well, is that a good goal? I mean, maybe if you had a really, really good way to prevent disease that didn't have those side effects, then sure. But if you don't, then and this thing is extending so many people's lives, and the absence of it would be a huge problem. You'd think, no, that is not a good kind of goal to have. And energy is, in a sense, a much, I mean, I don't know if it's harder than vaccines, but it's so fundamental in every aspect of the economy, and it's something where the time horizon of investment in terms of just how many investments we've already made to use fossil fuels through 2050 and how involved it is to change that, and how involved it, how disruptive it would be to try to use alternative technologies, even if they were good enough. But now, like, the alternative technologies people are talking about are not nearly good enough at all. And they're also completely dependent on fossil fuels. So there's just this whole phenomenon of acting like, oh, solar and wind are net zero. It's like, no, those are totally made using fossil fuels. Are only as cheap as they are because of fossil fuel mining and fossil fuel manufacturing and fossil fuel transportation. And then, as we've discussed in previous episodes, the whole way they operate is they operate parasitically on reliable energy systems, mostly based on fossil fuels. And they make those reliable energy systems less efficient because those energy systems have to cycle up and down like stop and go traffic to handle the unreliable fuel sources. So you're actually burning extra fossil fuels because of this parasitical destructive relationship that the unreliable fuels have on the reliable energy system. So just, like, what are you going to do to actually get to net zero? Like, there is no mechanism at all. And so I mean, right now, the way I think of it is a requirement of human survival and flourishing today is emitting CO2. That's just, it is a largely unpreventable side effect of human flourishing. And if you recognize that, then just like medical side effects today are an unpreventable, uh, largely unpreventable byproduct of human flourishing. It's not that now, you can do different things to limit different ones, but if you were to say no, zero medical side effects by 2050, well, medicine is how we cure ourselves, how we prevent ourselves from dying, and energy is how we live, including how we prevent ourselves from dying. So it's just this whole thing of, we're not looking at it from a human flourishing perspective. We're just looking at the side effects without looking at the benefits. And that has to lead to a disastrous decision in any field. And then the more fundamental the field, the more disastrous. And this is just about the most fundamental area. Stefan, what is your next story?
Last week, BP published its latest statistical review of world energy, and it now contains 2018 data. And this is a data set that I like a lot and work with a lot. And I just wanted to provide some trends and insights into that and put things into perspective, because what I observe a lot in commentary is, obviously a lot of hype for renewable energy and, how much they are growing and taking over the world. And so I think this data is a very good empirical way to sort of bring reality back into the discussion about energy. So the big news is total global energy consumption rose by 2.9%. Also, CO2 emissions rose a little bit, I think about 2%. Also, the proved oil reserves grew by over a billion barrels since 2017 and by over 235 billion barrels since 2008. So this is a concept of course, proved reserves. Reserves means how much oil we can extract given the current economic conditions and technical ability, right? And so they can grow over time because the raw material is not identical with the proved reserves. And the raw material is very abundant, and the proved reserves is, what we can extract with our current abilities. And that grew as well because of technical progress and some new exploration activity. So And overall, the world oil consumption grew by 1.2%, natural gas by 5%, and the coal consumption by 1.4% in 2018. Nuclear by 2.4%, hydro by 3.1%. I hope I don't overwhelm everyone with numbers, but I put them in perspective later on. So don't get overwhelmed just now. And one big news that's cited a lot here is that all non-hydro renewables, so that's wind, solar, geothermal, biomass, and so on, they all together grew by 14.5%. So you would think, yeah, this is a category that really took off last year, right? But to put things in perspective, they are all together making up just over 4% of global energy consumption right now, and just over 9% of global electricity generation. And another big thing often cited is solar consumption increased 28.9%. That's a lot. And wind consumption increased 12.6%. But notice that this all is relative change, right? So from the baseline, what's the percentage increase? So then I compiled, well, what are the different energy categories actually making up as a share of total consumption? The fossil fuel and our energy is derived, or was derived in 2018 from fossil fuels for 84.7%, hydro 6.8%, nuclear 4.4%, wind and solar only 3%, and with wind being 2 times the amount of solar as a subcategory. So 48.7% fossil fuels and wind and solar only 3% combined. Okay, that's a big picture perspective. That's what wind and solar, if they would really, power the entire UK or better the planet by 2050, that's a gap they need to close. And so overall perspective in absolute numbers, I find this very important to do, because what we are talking about is shares and percentage increases, but very few people have an idea of, what's the actual growth? How much material are we using from certain technologies? And I think it's very important to see, in my judgment, why solar and wind cannot catch up anytime soon, and probably never. So this is a measurement that's called million tons of oil equivalent. And this is sort of a unit where you can compare every technology. You can compare coal to wind consumption, right? So, and the increase of coal use in 2018 was 53.7 million tons of oil equivalent. Oil increased by 55.1 million tons of oil equivalent. Gas increased by 167.5 million tons of oil equivalent. So now in comparison, wind increased, you remember the big percentage points. Wind increased by 70.9 million tons of oil equivalent. That sounds like a lot. And solar increased by 29.7 million tons of oil equivalent. But what does this really mean? So think about it. So wind was a bit impressive. It grew faster in terms of energy than coal and oil, but it couldn't catch up with gas at all. It has less than 50% of gas in terms of consumption increase. And solar just barely makes it over half of the increase that coal had last year. So in that terms, wind and solar need to rapidly increase their growth rate, not just their growth rate needs to increase to just catch up with the increase of fossil fuel use in 1 year, right? So that's a big perspective. So they can never sort of catch up if they continue on these trends. They would actually have to increase their rate of increase to do that. And so there was an interesting comment by Roger Pielke Jr., who is an energy economist, besides other things that he does in sports statistics, I think. And he says for a 2050, quote unquote, carbon-free energy world, quote, we need 1 or 2 nuclear power plants worth of carbon-free energy to replace equivalent fossil fuels deployed every single day starting today to do that by 2050. So we would have to actually build these nuclear reactors like, I don't know what was Nikita Khrushchev thing, like sausages in a factory. That's the kind of growth that we would need from an alternative energy source. And so in my view, they can catch up, wind and solar. They get impressive percentage increases on their very low baseline, but that is by far not enough. And if we're talking about a time frame like 15 or even 30 years down the road, that's not possible. That's not at all possible. I also wanted to add something that BP in its press release related to this data set said. And they called this an unsustainable path. So they say, well, we need to do the transition to fossil-free or carbon-free energy by 2050 or something similar to that. And we are totally not on this path. So they agree with Roger Pickett Jr. and acknowledge that it's not. And the BP Group CEO Bob Dudley said at the presentation, the longer carbon emissions continue to rise, the harder and more costly will be the necessary eventual adjustment to net zero carbon emissions. And my thought to this is, okay, so BP is promoting wind and solar a lot, along with a lot of other organizations. And my big problem here is wind and solar just technologically aren't capable. As I said, they would have to increase their rate of increase again. But we are already seeing some saturation effects, when the subsidies go down and, the maturity of the technology from scaling it up from, small manufacturing to big manufacturing, this is coming to an end. And there aren't really like exponential increases possible for very physical reasons. You need to move material and manufacture a lot to create a wind turbine or a solar cell. And this cannot like go 10 times and 100 times again. It would saturate and decrease the rate of deployment, right? So, and really the only technology where this is even remotely possible, in my view, is nuclear power, because nuclear power right now uses only a fraction of the energy in the fuel. So there's an engineering potential to, tenfold, 20-fold the overall efficiency in nuclear. And we don't use a lot of nuclear. It's like 4.4% share of the total in the world right now. So we know how to build nuclear. We can improve on the process. We can probably develop there's a growth potential. And wind and solar are constantly hyped with a big growth potential, but they actually don't have enough growth potential. They can never, like in 2018, they didn't catch up. By the time they catch up, it's probably the 22nd century.
So I want to just focus on what I think is probably the most important and memorable data that you're talking about, which is that that fossil fuel use is actively increasing year to year.
Yeah.
And it's increasing more, significantly more than solar and wind. I believe gas itself is more than solar and wind combined in absolute terms. So when people are talking about, oh yeah, we got to get to net zero, like there's not even a trend away from fossil fuels, despite all of these efforts, despite what I've heard is $580 trillion in Germany. Just despite the fact that it's
billion,
in a sense,
not
it's easy.
trillions. We're not that rich.
Oh, sorry. Good catch.
I wish.
Until they have another hyperinflation, like in the Weimar Republic.
Then it's not dollars. Then it's Deutsche Mark or something.
That's right. Yeah, I guess it'll still stay the same with dollars. Good catch. Yeah. So you just the reality. The reality of the world is that people, despite doing a lot of self-destructive things in terms of using inefficient forms of energy based on unreliable fuels, people are still trying to empower themselves, and they're still not only overwhelmingly using fossil fuels, they're using fossil fuels as the new sources of power. And this is just not acknowledged in the discussion. I really liked Pilkey Jr.'s. He has a lot of good presentations on this, and I follow him on Twitter, and I find a lot of his content really, really interesting. And he's just saying, yeah, that's a really powerful idea. You need to build something like one nuclear plant a day. And even how are you going to, and that's the best kind of idea here. So I think that anyone who, to the extent people think about CO2 emissions as important, one thing is you're not going to get to net zero anytime soon without just absolutely catastrophic consequences that I really hope people are not willing to face. I think it's much more likely that certain stupid nations will be suckers but pretend to be leaders and then do very destructive things, although not Green New Deal level destructive, and then they'll pay a huge price, and then their economic activities will shift to other countries like China, and then they'll probably stop doing it. It seems, fortunately, I think it's very unlikely that the world will do anything this stupid. But if you are interested in it, I think one thing you have to be hugely interested in is, can you figure out a way to capture CO2? And so they're interesting kinds of technologies where, for example, they're saying, okay, well, we can capture carbon and then we can combine it with oxygen and we can make, totally clean burning, say, liquid fuel. No, sorry, combining it with hydrogen rather. And we can make, clean burning liquid fuel or even solid fuel. And I think those intrigue me more than underground gas storage, unless you had a way that the gas would dissolve. I just think it seems very untenable to just create so much underground gas and figure out places to put it. But if you could create a liquid or a solid, you have different kinds of options, particularly with a solid. So that's the kind of thing that people are interested in. But the fact that their whole focus is, let's use these unreliable fuels that the existing technologies themselves are dependent on huge amounts of fossil fuels to make and to run. That's not a serious thing. That's just they're supporting that as an excuse to attack fossil fuels and the civilization that they make possible. Okay, that is it for today. We had some good topics. If you have any questions, comments, love mail, or hate mail for us, send them to Don Watkins. He's don@industrialprogress.net. Also, if you would like one of us or someone else on our team to speak at one of your events, email don@industrialprogress.net, subject speaking. And if you are an organization that does any kind of high stakes messaging, whether for your employees or other stakeholders, and you'd like our help on that, email don@industrialprogress.net, subject consulting. Let's see what else. Make sure to get on the email list, which you can subscribe to very easily at alexepsteinlist.com. Good to be back today. Thanks again to Don and Stefan for handling the previous weeks. I expect to be back in most of the weeks to come. So next week, I expect to be back. We'll have a lot more interesting things to discuss. Until then, I'm Alex Epstein. This has been Power Hour.
Power Hour. Life, liberty, and the pursuit of energy. Power Hour. The antidote to shallow thinking about energy issues.